Okay, good morning everyone. Okay, I'm going to go through assignment 5 of mole concept, okay, on limiting reagent. Alright, so this will be the last set of assignment for the chapter of mole concept. So after this, I'll move on to another chapter called qualitative analysis. Okay, so let's take a look at this assignment. Okay, so you have 20 centimeter cube of ethene is reacted with 70 centimeter cube of oxygen, which is O2 lah. Okay, so ethene is this thing, oxygen is O2 lah. Okay, I hope you know this. Alright, so what is the total volume of gas remaining at the end of the reaction? So this you have, okay, so it doesn't matter to start from the point of view of ethene or oxygen. You should land up with the same conclusion. Alright, so I shall start with the ethene point of view. So 20 centimeter cube of ethene C2H4 will react with, okay, because the ratio is 1:3, right? So in this case, okay, 20 centimeter cube of ethene will react with 20 times 3, okay, which is 60 centimeter cube of O2, right? Okay, because don't forget all these are all gases, so mole ratio equals to volume ratio. Okay, so the mole ratio will be the volume ratio, so there isn't a need to convert the volume to mole in this case. Alright, then okay, you compare against what you have. This is what you need lah. Okay, what you have is over here. Okay, so in this case quite obvious. Okay, you have extra lah. Okay, O2 in excess, then ethene is limiting, right? Okay, so how much of O2 in excess so the volume of excess O2, take 70 minus 60 so this will be 10 centimeter cube. Okay, by the way, this is actually a O-level question, MCQ lah. Alright, okay, but there's quite a lot of working behind this MCQ itself. Alright, okay, right, then now we need to find out the volume of CO2 that is formed, okay, using the limiting okay. So which ratio should you use? Should you use the O2 to CO2 ratio? Is it this one? Or should you use the ethene to CO2 ratio? Alright, the answer is you use the ethene to CO2 ratio. Okay, because why? Limiting is ethene, right? Okay, so in this case, the volume of CO2, okay, be based on your ethene. So 1:2 so you take 20 times 2 so 20:40 in this case. Alright, so 40 centimeter cube. Alright, so my final answer that I need to answer to is the total volume of gas. Okay, so total volume of gas, so that will include the CO2 as well as the O2, so these two together okay, the excess CO2 I mean, as well as the volume of CO2 formed. Okay, volume of CO2 formed to be specific is this way so 10 plus 40, you get 50 centimeter cube okay, in total. So that's my final answer, right? Okay, so I need to add your excess O2 together with the CO2 form, right? Okay, of course, just now when we find out who is the limiting, I also can go from the oxygen point of view okay, I just briefly write at the side so 70 centimeter cube of O2 will react with, okay, ratio is 3:1, so I take 70 divided by 3 Okay, just hang on a second. Okay. Okay, so that will be 23.3 centimeter cube of ethene. Okay, this is what you need. Compare against with what you have. Okay, so not enough lah. Once again, coming out with the conclusion that ethene is limiting. Okay. Alright, so this case will conclude with ethene being the limiting as well. So then from there you can also find out that CO2, the volume of CO2 based on your ethene. Okay, so always find product using limiting, not the excess. Alright. Okay, so moving on. Okay, let's take a look at the next one, right? Okay. Okay, so 1 gram of zinc is reacted with 50 centimeter cube of 0.4. Okay, so this case very nice. They already tell you who is in excess. Most of the time, the structured questions for O level are quite nice in the sense they tell you what is the excess, what is the limiting. So just look out for that lah. Okay, don't really have to come up with the sentence like what we did earlier. Okay, to find out who is limiting. Okay, so yeah, right. So when it says excess, then no need to write the sentence already lah. Okay, so it's very obvious that the other one, which is the hydrochloric acid, is actually the limiting lah. Alright, okay, so this is the limiting, HCl is the limiting. Alright, it becomes very excess. Very obvious already. The other one is the limiting. Okay, so let's find the number of mole. Oh, okay, please add this in. Number of mole of HCl. Okay, so you are given, this one is the concentration. When you see the unit is mole per dm cube is concentration. This one is the volume. Okay, so remember from the first part of mole concept, concentration, volume, mole. Right. Okay, so the number of mole of HCl. Okay, I will take concentration multiply by volume, but volume must be in dm cube. So centimeter cube to dm cube conversion. Okay, divided by 100. The other way, multiply by 100. Okay, so concentration is 0.4, volume is 50 over 1000. Okay, so that will give us I realize there's a error in my solution. Okay, so this one you can work out the answer, 0.02 mole. Alright, let me see. I think there's an error in my answer. Okay, so there's an error in my answer version, so do make a change. Alright, okay, let me go back to here. Okay, so the next thing I have is the number of moles of hydrogen gas. Okay, so this one you must find using the mole ratio between limiting and product. Always use the limiting to find product. Okay, so limiting is HCl, 2 HCl is to 1 hydrogen. Okay, so the number of mole of H2 okay, you take 0.02 divided by 2, so that's 0.01. Okay, mole. Right, so always use the limiting. Take note of this. Okay, then moving on, I'm going to do part C. Okay, you're supposed to find the volume of hydrogen gas. Okay, so right, okay, and then you're told one more any gas is 24 dm cube. Okay, so very simple. Okay, just use the formula on gases. Okay, the mole times 24 to get volume of gas. If you want in dm cube okay, 24 dm cube. Okay, sometimes answer one in centimeter cube, then you do in centimeter cube, 24,000. Alright, so depending on what units the question wants. Alright, okay, so let's look at this one. The volume of H2. So this one you take the mole multiply by 24. So a mole is 0.01, you multiply by 24. Okay, so that will give you 0.24 dm cube. That's the final answer. Dm cube. Right? Okay. Okay, my handwriting very ugly. Wait, let me change. Okay. Right. Okay, let's take a look at the next thing. Okay, so the third question on lead to iodide. So lead to iodide is an insoluble salt. It is prepared by the reaction between sodium iodide. So sodium iodide is this fella. Then lead to nitrate is this fella, PbNO3. Okay, I hope you haven't forget all your formula. Okay, so name the experimental technique used to separate lead to iodide. Okay, so lead to iodide is insoluble. So you can see it's solid. Comes out as a precipitate. Okay, this one will come out as a precipitate. Okay, since now you do quite a bit of practical, you should be familiar with this term called precipitate. Basically an insoluble salt. Okay, which is an insoluble salt, we call it a precipitate. Alright, so done using precipitation, of course. Okay, so this salt preparation technique, we call it precipitation. Okay, we should have learned. Okay, remember to start with 2 solutions back in N level. Okay, it's quite a big chapter, salt preparation. So I hope you haven't forget about it. Since salt prep acid and bases is inside your term review. I'll prepare some summary notes okay, in preparation for your term review. Okay, so next one, let's look at part A itself now. Okay, so name the experimental technique used to separate lead to iodide from the reaction mixture. Okay, so since it's a solid and then you have 2 solutions. Okay, so basically how it looks like is this way okay, so let's say you put your sodium iodide inside here, then you throw in your lead 2 nitrate. Okay, then you'll see this precipitate. Okay, so what you need to do next is, of course, filter this out right? Okay, filter this out so the technique we are using here is filtration. Okay, so I hope you haven't forgotten about simple separation technique like what you've done in N levels. Okay, this is nothing new actually. Okay, so let's look at part B, which is the more of the mole concept part. Okay, so 50 centimeter cube of 0.1 mole of sodium iodide, okay, is mixed with an excess. Okay, so excess is lead to nitrate. So in this case, lead to nitrate, this fella is excess. Okay, that means your sodium iodide is actually the limiting. Okay, so you are given volume, concentration again. Very common thing you will be given when solution. So this is volume, this is solution. Okay, so this one fella is the limiting. Alright, sodium iodide, NaI, is the limiting. Okay, so first thing you need to find is to find the number of mole of NaI. Okay, actually number, you can write in short form, NO. Okay, so this one is the concentration volume mole formula. So concentration multiplied by volume, but volume must be in dm cube. So once again you need to convert centimeter cube to dm cube. Alright, okay, you don't need to write this. Okay, as you get better, I wouldn't write this already. Okay, 50 over 1000. So that would give me, let me see, 0.005 moles. Okay, next thing you are required to deduce the number of moles of your lead to iodide made in the reaction. Okay, so let's take a look at this lead to iodide. Okay, so you must use the limiting to find out. Okay, limiting is sodium iodide, so mole ratio. So this one you use mole ratio, okay, between limiting and product. Okay, so limiting is your NaI. They will tell you who is excess. Then the other one is the limiting. Usually the question works this way. Is to lead to iodide. Okay, but if never tell, then it's a tougher question. Then the one too bad. Then you have to write out a sentence and figure out who is limiting, like what we do in the notes. Yeah. Okay. The exercises in this particular assignment are all actually O-level questions. Yeah. So far, I think O-level has been quite nice in combined chem to ask you to. They tell you who is the excess, then the other one is the limiting. Yeah. Hopefully you won't have to write the sentence. Yeah. I don't know until the day itself when the question come out. So far no lah. Yeah. Okay, so the number of moles of your lead to iodide based on your sodium iodide, which is the limiting, is this. Okay, 0.005 divided by 2, so that's 0.025 moles. Alright, so final answer, that's 1. Okay, and lastly I must find the mass, okay, in grams of lead to iodide. So what I do is this. I take, okay, this one is the mole MR mass formula. This one you done in N level already. Okay, so I want to find the mass of lead to iodide. So you take the mole multiply by the MR. So mole is 0.0025. MR, you have to look up the periodic table. In this case it should be 461. Okay, just let me double confirm. Okay, okay, 5, wait let 2 iodide, okay, 461, alright, 461 so this is 1.15 grams. Actually, by right is molar mass. It's very lazy. This is actually by right molar mass. Got difference one, molar mass and relative. MR means relative formula mass. Okay, got difference one. Okay, molar mass got unit one, actually gram per mole. Yeah, to be specific, it should be molar mass. Just after a while, I'm very lazy. I just can't write MR. Okay, right. Okay, then next one okay, let's move on already to question number 4. Okay, so a solution containing 3.8 grams of magnesium chloride is reacted, okay, with an excess of aqueous silver nitrate. Okay, so okay, yeah, very kindly told who is the excess. Excess is silver nitrate, so that means this fella, magnesium chloride, I hope you know what it is in the formula, MgCl2 okay, is actually the limiting. Okay, silver nitrate is actually the excess. Yeah, right. Okay. Okay, so right. Okay, let's see okay, let me jot down the equation over here so I got a bit more space. Okay, alright, just know in you which one is limiting, which one is excess actually you don't have to copy down word for word what I do alright, okay, after a while you kind of get, but this is a start so that's why I'm a bit more detailed in a sense. Yeah, alright, okay, so MgCl2 is a limiting. Okay, you are given this this is 3.8 grams is actually the mass. Okay, 3.8 grams that's the mass. Okay, so you are supposed to find the mass of your silver chloride, which is this fella Okay, so what we need to do is, okay, obviously must turn it to the mole first. Okay, so that one is a 3-step process over here. Mole, MR, mass. Okay, or molar mass okay, to be very specific. Actually this thing should be supposed to be molar mass. Okay, I don't keep on writing MR, then you go with the impression that it's actually that's like lazy, but it's the same number. Alright, okay, this, yeah, MR and molar mass is the same number. Okay, so I want mole, so I'll divide by MR. Okay, then after that mole ratio over the mole ratio is 1:2, so I'll times 2 okay, to get the number of mole of silver chloride. Okay, then go to the mass by multiplying by the MR silver chloride. Okay, please don't include the 2 in your MR calculation alright, okay, so that's the plan down here. Alright, okay, okay, so now let me present out the working. I'm a bit short of space, so I might just write it over here okay, so first thing I do is the number of mole of MgCl2. Okay, that one I do the mass over MR. Mass is 3.8. Okay, let me get the MR. MR is 24 plus 2 times 35.5. So that will give us 0.04 moles. Okay, so limiting in this case is MgCl2, so you use mole ratio between limiting and the product okay, so this part always take note use mole ratio between limiting and your product. Sorry. Okay, so next thing I can find is the number of mole of my silver chloride AgCl. Okay, so you get 0.08 mole. So the mass of your AgCl mole multiplied by MR. So that's 0.08 multiplied by MR of silver chloride, which is 108 plus 35.5. Okay, so 11.5 grams. Okay. Alright, so final answer 11.5 grams. Sorry for my sneeze just now. Okay, and the final question now. Okay, let's see. Okay, final question you are told is excess zinc, and then hydrochloric acid would naturally be the limiting. Alright, so this fella is the limiting. Zinc is the excess. Okay, anyway, no info given on the excess. Right, so okay, let's take a look. So this one you are using the concentration volume mole. Okay, so first thing I need to find is the number of moles of HCl. Okay, so you are given this is 100 centimeter cube. This is the concentration. So I'm supposed to find the number of mole by taking concentration multiplied by volume. Then after that, mole ratio over. And finally, you can get the volume of your hydrogen. Okay, this one you times 24 dmq. This one will be the mole 24 volume formula. Right. Okay, so let's take a look at this. So first thing first, the number of mole of your HCl. So you do concentration multiplied by volume. So volume must convert lah. Okay, concentration 0.1. Volume, always remember, convert from centimeter cube to dm cube before calculation. Okay, so this will give you 0.1 mole. Right? Okay, right. Okay, so next thing, I use the mole ratio between my limiting as well as my product. Okay, so the number of mole, okay, use this one, no need, right? I just writing a comment to tell you only. Use mole ratio between limiting and product. Okay, so it's just a comment to tell you lah. Okay, so 0.1 divided by 2, so 0.05 moles. Okay, next thing, I can find the volume of H2, right? So I done this step. Okay, I can find the volume of H2 already by taking mole multiplied by 24. So 0.05 multiplied by 24. So that will be 1.2 dm cube. Yep, done. okay. So once okay, then yeah. Then yeah, I think that's it for this exercise. Yeah, I'll end the video here.